In the previous lecture, I took time out to try and define agriculture, and we saw that defining it is quite a subtle problem. So it was worth taking a fair bit of time to explain what precisely the nature of that threshold was. Because only once we've defined it clearly and we understand the nature of the threshold can we really explain it and then understand its impact. We also talked in general terms about why agriculture had such a revolutionary impact. We saw that the appearance of agriculture counts as one of our great thresholds of complexity, and it'll generate new emergent properties that are going to transform human history, absolutely transform it. We also saw that, like other thresholds, that there are some intriguing similarities between this threshold and other thresholds, including the creation of the first stars. Now, what I want to do in this lecture is begin, or try to explain, to offer an explanation of agriculture. We begin by discussing the evidence that we can use to trace the origins of agriculture, and then I'm going to try and explain or offer an explanation for this revolutionary turning point. Why did humans, in so many different parts of the world, some of them completely disconnected from each other, suddenly start getting their food and energy in entirely new ways in a series of different parts of the world? When I say sudden, I mean sudden in comparison with the 200,000 years or so of the Paleolithic era. We'll see that agriculture pops up quite independently in several quite distinct regions. Evidence. We have to ask the question again, how can we know about events that occurred many thousands of years ago, long before the appearance of writing? Agriculture appeared at least 6,000 years before there were written records of any kind anywhere in the world. So this is a topic, once more, that we must study through archaeology. How? Rather than discussing the evidence abstractly, we can get a feeling for the sort of evidence that archaeologists use in handling this issue by looking at the so-called Natufian people and a closely related group, the Kebaran people. And here I'm making a lot of use of the work of Stephen Mitham, whose book After the Ice offers a sort of imaginary tour of life since the last 20,000 years by a fictional character that he calls Lubbock, after the 19th century British archaeologist of the same name. So what happens is we follow Lubbock, who's a sort of time traveller, we follow him right around the world to a number of archaeological sites. And what he does is he visits them in real time, so we actually see through Lubbock's eyes what people were doing. It's a lovely way for a non-archaeologist to get a feeling for the relationship between what archaeologists actually find, which often doesn't look terribly exciting to a non-archaeologist, and the real lives that the archaeologist can construct from that evidence. So, Lubbock watches these people as they go about their daily lives, and it's a very vivid and powerful way of getting a sense of how archaeologists reconstruct the past. The Natufian people. Back to the Natufians. The Natufian people lived in the Fertile Crescent in modern Jordan and Israel from approximately, and all dates for this period, I always have to say approximately, from approximately 14,000 to about 12,000 years ago. Let me just try and describe what I mean by the Fertile Crescent. It runs north from the Nile, along the eastern edge of the Mediterranean shore through Israel, Palestine and Lebanon to southern Turkey, then curves east and curves down along the border between modern Iraq and Iran and down to the Persian Gulf. Natufian sites illustrate some of the techniques and the challenges of the sort of research archaeologists do when they're trying to study early agriculture. Now, here are some of the distinctive features of Natufian sites. First, Natufian sites are strikingly different from those of most of the sort of foraging populations you find if you're studying the Paleolithic world. Their dwellings in general were more substantial. They were often built into the ground for warmth. And they were built with well-built dry stone walls. So these are sort of dwellings that are much more substantial than the sort of dwellings that were built by foragers throughout most of the Paleolithic era. Secondly, they seem to have been sedentary. By sedentary, I mean they seem to have stayed in one place most of the year, which is something that farmers conventionally do. Now, they may have left for a few weeks, but they're in one place for most of the year. How do we know this? Well, Natufians hunted gazelle. So you find lots of gazelle bones at these sites, and this is an illustration of some of the things that archaeologists can do with bones. You can tell from the growth bands on the gazelle teeth what age they were and what time of year they were hunted. And what this evidence shows is that they were hunting gazelle all year round from the same place. So that's one of the pieces of evidence that they were pretty sedentary. And the other, of course, is the piece we've already seen, that they built these very solid, durable houses, not the sort of things you build and then leave for 11 months. A third feature of the Natufians is that they clearly harvested grains. This is a surprise for a foraging population. You find in Natufian sites grindstones, and you can detect what they've been used on, and it turns out what they were used on was emmer, which is a form of wheat. That's spelled E-M-M-E-R. And you also find in Natufian sites sickles. They're made by setting flint blades into bone handles, often made from the jawbones of gazelles or other hunted animals. Now, archaeologists can study the edges of these sickle blades through microscopes, and what it shows is that they had been used clearly to harvest grains. You can find the remnants of this, you can find clear evidence of this. Now, all the evidence we've seen so far looks like an agricultural village. They're sedentary, they have solid houses, they're harvesting grains. But some of the evidence in these villages doesn't fit in with this picture at all. And the first thing is that if you analyze the grains that they were harvesting, it turns out they were not from domesticated, but from wild species. Now, how can archaeologists tell this? By studying grain pollen, archaeologists can distinguish, for the most part, between wild and domesticated species. This applies to plants, and also they can do the same thing, by and large, by studying animal bones. So very often archaeologists can distinguish between wild and domesticated species. The fact that the grains were wild showed that they were not farmers. Instead, they were sedentary or semi-sedentary foragers. Later, we'll see how study of the Natufians has helped us to solve some of the puzzles that surround the agricultural revolution. But we have already seen examples of sedentary or semi-sedentary foragers. Okay, now let's try to explain the agricultural revolution. In the previous lecture, we saw that agriculture appeared within just a few thousand years in many different parts of the world. So this is actually very odd. Why, after living apparently quite contentedly as foragers for perhaps 200,000 years, should humans suddenly start using an entirely new set of technologies? And why, when they did so, did human communities in quite separate parts of the world start doing so nearly simultaneously? The simultaneity of this is very strange indeed, and any decent explanation of the agricultural revolution must attempt to explain it. Here's a quotation from two recent researchers on the subject of early agriculture, Price and Gebauer. In a book called Last Hunters, First Farmers, they write this. For some reason, beginning around 10,000 years ago, hunters became farmers in a number of different places on the planet. The intentional cultivation of domesticated plants was an almost simultaneous, yet completely independent development in Southwest Asia, by which they mean Mesopotamia, the Fertile Crescent, Southwest Asia, China, and Southeast Asia, Mesoamerica, South America, and the eastern United States, transpiring within a period of approximately 5,000 years. That's the problem we have to explain agriculture. Why this odd simultaneity? Now, let's immediately rule out two explanations that might be tempting. Let's begin with extraterrestrials. This is one that I found I'm always going to have to deal with when teaching this subject. The near simultaneity of the appearance of agriculture certainly tempts many of my students to remember Stanley Kubrick suggesting in 2001 that extraterrestrials nudged humans towards the technology of hunting. So let's just clear this one out of the way straight away. You remember 2001, you remember the monoliths, that they nudge humans towards civilization of some kind by planting ideas in the minds of hominines of various kinds. Well, we're not going to even look at an idea like this, of course, until we can find some concrete evidence. So let's just get that one out of the way. We have no concrete evidence for this. We have to find a subtler way of explaining this. Now, here's a much more serious and much more influential idea about the origins of agriculture. It probably dominated explanations of this phenomenon in the 19th century and for much of the 20th century. And it goes like this. The idea is that agriculture appeared as a brilliant one-off invention, a bit like, say, the steam engine or the internet. And it was such a brilliant invention that once it appeared, people naturally took it up. So what it did was it diffused from the center where it first appeared around the world. This we can describe as a diffusionist explanation of agriculture. Such explanations are tempting because inventions do indeed spread rapidly around the world. There are many phenomena that do diffuse rapidly. And these explanations were particularly fashionable in the late 19th century because they carried some nice implications for European scholars. In an age of imperialism, they carried the implication that all the good things diffuse from high civilizations to simpler civilizations. And that was very much the thinking behind 19th century diffusionists. And the idea was that agriculture first appeared probably in somewhere like Egypt, maybe Mesopotamia, and then spread to lower civilizations. Now, as we'll see, there are very good empirical reasons for rejecting diffusionist arguments for the initial origins of agriculture. Diffusionist arguments will be very important once we try to explain how agriculture spread from these initial points where it first appeared. But at the moment, they cannot explain why it first appeared, and above all, they cannot explain this sort of near simultaneity that we've looked at. So, diffusionism is now rejected broadly as a general explanation for the initial appearance of agriculture. There are several reasons for this. One is that agriculture was not a single invention, like the steam engine. It's actually a cluster of linked innovations requiring entirely new lifeways. It was not the sort of thing you could have taken a patent on. Agriculture implied the domestication of crops and animals, techniques for weeding, elementary forms of irrigation. It implied discovering the best ways of planting, protecting and harvesting particular crops, as well as storing them. It also required new social rules, such as rules about who owned what. So the puzzle is to explain a whole cascade of changes, not just a single intervention. Besides, we'll see that agriculture did not necessarily improve living standards. It was not necessarily so attractive that every foraging community that learnt about it was bound to take up agriculture. Modern studies of modern foraging societies have shown that many deliberately reject farming. They see farmers, they know how farmers live, and they don't want to live that way. So we shouldn't assume without careful thought that agriculture necessarily represents an improvement in the way people lived. Archaeological evidence suggests that those foragers who rejected the agricultural lifeway may have had some good reasons for doing so. For many early farmers seem to have suffered from poor health and nutrition. We can tell this from archaeological evidence, such as an increase in the number of stress lines in the bones of early farmers and a decline in average height. Now, this fact, this indirect evidence that living standards may have deteriorated in some early agrarian communities affects how we explain agriculture. If agriculture was not such an attractive lifeway, perhaps we need to focus more on the push than the pull. In other words, we need to look for factors that pushed people into agriculture rather than factors that lured them into it, as in the 19th century diffusionist model. And the third reason for rejecting that 19th century model is that, as we've seen, agriculture wasn't invented once but many times. There's not just one point from which it spreads to the rest of the world. Diffusionism can't explain this near simultaneity we've looked at, though it will explain the later spread of agriculture. Now, we've seen some of the difficulties of explaining agriculture. It really is quite a tricky threshold to explain. Modern explanations include several interlocking factors. And I have to admit straight away, there is as yet no completely uniform consensus on exactly what is the best way of explaining how agriculture first appeared. There's still plenty of room for debate on the issue. However, most explanations refer to the same basic factors, even if they may link them in slightly different ways. Here, I'll propose a possible explanation in five main steps just to try and clarify the logic of the argument. Unlike some models you may come across, you should note that this is a push model. It assumes that, by and large, humans were eventually pushed into agriculture rather than lured into it. Something happened that forced them to take up agricultural lifeways. It's not a pull model like the diffusionist argument we've just been talking about. Okay, here are our five main steps in trying to explain the initial appearance of agriculture. The first of them is pre-existing knowledge, by which I mean that modern studies of foraging communities have shown over and over again that they have an immense amount of knowledge about the organisms surrounding them, the plants and animals, particularly those that they use for food. They have an immense amount of knowledge, and very often that knowledge includes knowledge about how to increase the production of this particular plant or this particular animal. We've seen that fire stick farming, for example, is an example of ways that foragers could increase the productivity of a particular area. The problem, therefore, is not knowledge. It's not that foragers didn't know many of the things you need to know in order to farm. They had the knowledge, so it looks as if they simply didn't need to intensify production. So the problem is to explain why foragers suddenly start applying this knowledge much more vigorously. The knowledge was not new. The puzzle is why they begin to apply it on a large scale. So that's the first step. A lot of the knowledge you need for agriculture already existed. Now the second step. The second step is the distribution of potential domesticates. Some animals and plants can be domesticated quite easily. Wheat is an example. Others can't be domesticated so easily. Kangaroos are an example of that. So the exact way that animals and plants were distributed may help us explain the geographical distribution of early agriculture. In some regions, there were organisms that could be turned into domesticates very, very easily indeed. In other areas, it was tougher. Jared Diamond has pointed out in his bestseller Guns, Germs and Steel that the Fertile Crescent, where the Natufians lived, had a remarkable number of species that can be domesticated with only fairly minor changes. So this is the second point. Other regions had fewer easily domesticated species. The Americas, for example, had far fewer promising animal domesticates. Now, you may remember why. The reason may be that early humans in the Americas actually hunted them to extinction. There were very few large mammals in the Americas after the megafaunal extinctions of the end of the Paleolithic era. So perhaps the availability or non-availability of easily domesticable species in an area may help us explain why it appeared in some regions rather than others. It's sheerly a matter of luck, the sort of organisms around you. That's the second factor. So we've looked at pre-existing knowledge and now the geography of domesticates, a third factor. Population pressure. Now here's where the analogies with star formation are most tempting. Population pressure is similar to the build-up of pressure that created the first stars in the earliest solar nebulae. But we'll see that growing population pressure, we can imagine how it could have driven humans into agriculture. There's more population, you suddenly start worrying about starvation, so you start thinking, well, we must find ways of producing more food from a given area. So it's a promising-looking argument, but it probably cannot explain the emergence of agriculture on its own. It's been proposed in the work of a prehistorian, Mark Khói, who's done very important work on the life of early farmers and on the transition to agriculture. He's shown that as foragers migrated around the world, population may have built up in a very loose sense, in the sense that humans by 13,000 years ago had entered all the large areas of the Earth that were previously unoccupied by humans. So by about 10,000 years ago, there are no new continents for humans to enter. And this may put an end to extensification, the process I described before. The fact that to support growing populations, you can simply migrate to a new area. Now that possibility is being closed off. The Paleolithic frontier, if you like, has been closed. Now that's a tempting argument, but there's a problem with it. And the main problem is this. Studies of modern foragers show that foragers are often very conscious of population pressure. In other words, they have a very good idea of how much their land, how many people their land will support. And that means that very often they systematically limit population growth. This may mean several things. It may mean prolonged breastfeeding, which limits fertility. But it may mean more violent methods, such as killing the weaker of two twins, which seems to have been a fairly common practice, or allowing the old to die, infanticide and senilicide. Now, if that's true, it means overpopulation shouldn't have been a problem. Hunter-gatherers or foragers could adjust by simply limiting population growth. The argument's tricky in another sense. By modern standards, the world was grossly underpopulated 10,000 years ago. But of course, it could still have been overpopulated given the fact that foragers needed such huge areas to survive. So that's the third argument, overpopulation. It's tempting, but before we can use it, there are problems. So let's see if we can overcome them. Here's the fourth factor, and this may be a way of explaining how population growth worked. Sedentism. Sedentism as a cause of population growth. Here the Natufians may help us solve the riddle. They settled down, we saw. They were foragers, but they settled down. And once they settled down, their populations began to grow fast. We can see this in the rapid spread of Natufian villages in the Fertile Crescent. Why would their populations grow? Well, this was probably because once you're settled down and you have this abundant resource, this wheat and these gazelles around you, and you don't need to carry the old or the very young, there's less need to limit population size. So once you're sedentary, perhaps population's going to start growing more rapidly. Okay, so that's the fourth factor. Sedentism may lead to rapid population growth, which may force them to start looking for new ways of getting food. But why would they settle down? Now that takes us to the fifth part of this argument, the fifth step. And here we introduce the one factor that we know affected the entire world and is therefore the best possible explanation for the simultaneity of this, and that's climate change. The last ice age reached its coldest stage about 20,000 years ago, and after that, climates began to get warmer, particularly after about 14,000 years ago. By 11,500 years ago, after a brief cold snap, they had reached temperatures similar to those of today. And during the interglacial of the last 10 to 11,000 years, climates have generally been warmer, wetter, and more stable than those of the Ice Ages. Now, this fact affected the whole world, but how could this have triggered more sedentism and more population growth? Well, here's a possible argument. One way of dealing with this is associated with the work of two Californian scholars, Peter Richardson and Robert Boyd. Now, what they argue is actually the simplest argument of all. It is that during the Ice Age, climate change was so erratic that sustained agriculture was simply impossible. You couldn't do it during the Ice Age. So their argument is, well, once you get stable, warmer climates, foragers knew how to do agriculture. It was simply impossible before, so it's no surprise they start doing it. So their argument implies that perhaps climate change is virtually the single key factor in the origins of agriculture. As soon as agriculture became possible, humans started doing it. Now, any argument, as we've seen, for which climate change is crucial is attractive because climate change is a global phenomenon. But this argument on its own isn't quite going to work, particularly if we're not persuaded that foragers are going to like the idea of farming. So here's another approach: Gardens of Eden and the trap of sedentism. Warmer, wetter climates undoubtedly led to regions where certainly plant growth, but also animal populations were more abundant than they'd been during the Ice Ages. So this may have meant there appeared sort of pockets which archaeologists describe as Gardens of Eden, areas of great abundance. Now, modern studies of foragers suggest that when they find such regions, foragers will often become more sedentary. And foragers who become sedentary are often described as affluent foragers. They're found in environments of exceptional ecological abundance. The classic example here is the northwest coast of the USA, where many foragers settle down, relying on the abundance of resources such as salmon. So this may explain why groups like the Natufians began to settle down. But this can be a trap. And I'll call this the trap of sedentism. Once you're sedentary, populations start growing. And this is going to mean that within just a few generations, you're going to find that what seemed an environment of abundance is now an environment of scarcity. You have to increase food production in order to feed everyone. So sedentary foraging communities who've now lost probably many of their traditions as foragers find they're going to have to increase production. There's probably not spare land around them. They're going to have to tend their crops more carefully, water them, weed around them. In short, they're going to have to become farmers. Now, in this rather roundabout way, population pressure, may have played as powerful a role in the appearance of agriculture as it did in the appearance of the first stars. Now, arguments like these work well in the Fertile Crescent. Natufians almost certainly had a good understanding of natural plants. They lived in a region with many promising domesticates. We know that as they became sedentary, populations grew rapidly. We know that warming climates may have encouraged them to become more sedentary. And finally, we know that farming villages appeared quite rapidly after a period of cooler climates, which put a lot of stress on local populations from about 11,000 years ago. So, the argument works well in Mesopotamia, in the Fertile Crescent. Elsewhere, the mix of elements may be slightly different, but by and large, you should expect to find most of these factors wherever we find early agriculture. In Mesoamerica, nomadic foragers may have cultivated crops of maize before they became fully sedentary, but with these slight differences, the story may hold up in most parts of the world. Thank you. And we saw that defining it is quite a subtle problem. So it was worth taking a fair bit of time to explain what precisely the nature of that threshold was. Because only once we've defined it clearly and we understand the nature of the threshold can we really explain it and then understand its impact. We also talked in general terms about why agriculture had such a revolutionary impact. We saw that the appearance of agriculture counts as one of our great thresholds of complexity, and it'll generate new emergent properties that are going to transform human history. In the previous lecture, I took time out to try and define agriculture, absolutely transform it. We also saw that, like other thresholds, that there are some intriguing similarities between this threshold and other thresholds, including the creation of the first stars. Now, what I want to do in this lecture is begin, or try to explain, to offer an explanation of agriculture. We begin by discussing the evidence that we can use to trace the origins of agriculture, and then I'm going to try and explain or offer an explanation for this revolutionary turning point. Why did humans, in so many different parts of the world, some years before there were written records of any kind anywhere in the world? So this is a topic, once more, that we must study through archaeology. How? Rather than discussing the evidence abstractly, we can get a feeling for the sort of evidence that archaeologists use in handling this issue by looking at the so-called Natufian people and a closely related group, the Kebaran people. And here I'm making a lot of use of the work of Stephen Mithen, whose book After the Ice offers a sort of imaginary tour of life since the last 20,000 of them, completely disconnected from each other, suddenly start getting their food and energy in entirely new ways in a series of different parts of the world. When I say sudden, I mean sudden in comparison with the 200,000 years or so of the Paleolithic era. We'll see that agriculture pops up quite independently in several quite distinct regions. Evidence. We have to ask the question again. How can we know about events that occurred many thousands of years ago, long before the appearance of writing? Agriculture appeared at least 6,000